I request the organizing secretary of the e-conference, Reverend Father G. Kiran Kumar, and the convener of the e-conference, Sri M. Mariadas Garu, to start the proceedings.
Good morning, sir. Good morning, all.
Good morning, Father.
Good morning, sir. Shall we begin? Wait for 2 or 3 minutes.
We will wait for 2 more minutes, Father. Since people are joining, we will wait for 2 minutes and then we will start, Father.
Okay, sir.
Thank you, Father. We acknowledge the presence of our resource persons, Dr. Ambrose Babu Garu and Dr. Tirupura Sundari Madam. Hearty welcome to both of you. Hearty welcome, sir. Hearty welcome to you, Madam.
Thank you, sir.
Thank you, sir.
Shall we start, Father?
Yes, sir. So, good morning to one and all. Once again, welcome back to the day 2, second day of our International E-Conference on recent trends in mathematical sciences. I thank all those who have cooperated us today by participation, by presenting papers, and listening to the resource persons. So today also, we request all of you to stay back till the end of this program, and you'll be enlightened with the invited talks. And so, may I request all to stay back till the end of this program today. And now, may I request Mr. M. Mariadas Garu to give the proceedings of today's program.
Thank you very much, Father. Thank you very much, Father.
Thank you, sir.
I thank the Lord Almighty for keeping us all sound and safe and bringing us back to the Day 2 deliberations of the International E-Conference on recent trends in mathematics organized by Department of Mathematics, Andhra Loyola College. I welcome you all. And without any delay, may I now invite Sri B. Solomon Raju, Senior Manager, PwC, California, USA, to deliver his lecture.
Hello, this is Raju Solomon Bandanadam. I'm a proud alumni of Andhra Loyola College undergraduate batch 92 to 95. I'm currently working as a senior manager in PricewaterhouseCoopers in San Francisco, California. I've done my major in mathematics in Loyola College, and then I did my master's in mathematics and computer science in my post-graduation. It's great to hear that the Andhra Loyola College has completed 67 years of excellence in higher education, and always proud of Loyolite. I would like to take this opportunity, and I am sure every Loyolite will join with me proudly to congratulate and thank all the great people's hard work. It's a great privilege and my honor to participate and share as a speaker in the International E-Conference. Today, I'm going to explain about the quadratic formula. That is today's topic I'd like to share, and how it serves an important role in the mathematical science perspective of the world that we live in today. Before we jump in, I'd like to go quickly the history behind the evolution of this quadratic formula. The Indian mathematician Brahmagupta, at the time of 597-668 AD, explicitly described the quadratic formula in his treatise Brahma Siddhanta, published in 628 AD, but written in words instead of symbols. The 9th century of Persian mathematician Muhammad ibn Musa solved quadratic equations algebraically. In 1637, René Descartes published a law geometry containing special cases of the quadratic formula in the form we know today. What is a quadratic equation? A quadratic equation is a second-degree equation of the form ax squared plus bx plus c equals to 0. Here a and b are the coefficients. C is the constant term and x is the variable. Since the variable x is of the second degree, there are two roots of answer for this quadratic equation. The roots of the quadratic equation can be found by either solving by factorizing or through the use of the formula. What are the real-life applications of the quadratic equations? The quadratic equations are used to find the zeros of the parabola and its axis of symmetry. There are many real-world applications of quadratic equations. For instance, it can be used in running time problems to evaluate the speed, distance, or time while traveling by car, train, or plane. The quadratic equations describe the relationship between the quantity and the price of a commodity. Similarly, the demand and cost calculations are also considered quadratic equation problems. It can also be noted that a satellite dish or a reflecting telescope has a shape that is defined by a quadratic equation. How are the quadratic equations different from a linear equations? So a linear degree is an equation of a single degree and one variable, and a quadratic equation is an equation in 2 degrees and a single variable. A linear equation is of the form ax plus b equals to 0, and a quadratic equation is of the form ax squared plus bx plus c equal to 0. A linear equation has a single root, and a quadratic equation has 2 roots or 2 answers. Also, a quadratic equation is a product of 2 linear equations. I'd like to share my screen before we dig into it. How to simplify a quadratic equation? The first step in the process of simplifying a quadratic equation is to transform it into a standard form ax squared plus bx plus c equals to 0. Further, it can be simplified by finding its factors through the process of factorization. Also, for an equation for which it is difficult to factorize, it is also solved by using the formula. Additionally, there are a few other ways of simplifying a quadratic equation. Now, we ask, what are the 4 ways to solve the quadratic equation? The 4 ways of solving quadratic equations are: number 1, factorizing the method; number 2, formula method; number 3, method of completing squares; number 4, graphing method. In this present image, ax squared plus bx plus c equals to 0 is the standard formula of the parabola. I'm going to explain the color coding of this: red color, blue, and then pink color. Come to the red color diagram. The formula where x is equals to negative b plus or minus the square root of b squared minus 4 times a times c over 2a will allow us to find the x-intercepts. The c here represents the y-intercept. And back to the blue color. Now let's take a look at the term negative b minus 2a. This equation corresponds to the position of a symmetry axis of the parabola. With that in mind, we can find the vertex of the parabola using the same equation for the x value. And using the equation negative b squared minus 4ac over 4a in order to find the y value of the vertex of the parabola. And coming back to the equation that is in pink, colored in pink. Lastly, the parabola contains a set of all points in a plane which are equal distance away from the given line, which is known as the focus. It is significant through the formula negative b divided by 2a 1 minus b squared minus 4ac over 4a. The directrix, of the other hand, is perpendicular to the axis of symmetry of a parabola and does not touch the parabola. As can be seen, the formula would be y equals to negative 1 plus b squared minus 4ac divided by 4a. And now we can ask a question: how do you solve a quadratic equation by factoring? The quadratic equation can be solved by factorization through a sequence of 3 steps. First, split the middle term such that the product of the split terms is equal to the product of the first and the last terms. Let us assume the quadratic equation is the form of x squared plus a plus b times x plus ab equals to 0. And it can be split as x squared plus ax plus bx plus ab equals to 0. As a second step, take the common term from the first 2 and the last 2 terms. X times x plus a plus b times x plus a equals to 0. X plus a, x plus b equals to 0. Finally, equalize each of the factors to 0 and obtain the x values. X plus a equal to 0 and then x plus b equal to 0. And hence we can obtain x equal to negative a and x equal to negative b. Now we can ask a question: how to solve a quadratic equation by completing the square. The quadratic equation is solved by a method of completing the square, and it uses the formula where we see a plus b whole square equals to a square. Now the next question will arise: how to find the value of the discriminant. The value of the discriminant in a quadratic equation can be found from the variables in constant terms of a standard form of the quadratic equation. Ax squared plus bx plus c equals to 0. The value of a discriminant is d equals to b squared minus 4ac. And it helps to predict the nature of roots of the quadratic equation without actually finding the roots of the equation. How do you solve quadratic equation with the graphing? The quadratic equation can be solved similarly to a linear equal by graphing. Let us take the quadratic equation. Ax squared plus bx plus c equals to 0 as y equals to ax squared plus bx plus c. Here we take the set of values of x and y and plot the graph. These 2 points where this graph meets the x-axis are the possible solution of this quadratic equation. Now, how to find a natural roots of the quadratic equation? Let's go into it. The discriminant is helpful to predict the nature of the roots of the quadratic equation. Well, the determinant of a quadratic equation ax squared plus bx plus c equal to 0 is b squared minus 4ac. The discriminant is referred as d equals to b squared minus 4ac. If d is greater than 0, the roots are real and distinct. For d equal to 0, the roots are equal. And for d is less than 0, the roots are imaginary complex numbers. Now, if you think about how important is a discriminant in determining the natural roots of quadratic equation, the discriminant is very much needed to easily find the nature of roots of the quadratic equation. Without the discriminant, finding the nature of the roots of the equation is a long process, as we first need to solve the equation to find both the roots. Hence, the discriminant is as important and the needed quantity, which helps to easily find out the nature roots of the quadratic equation. Now, our next question could be, how is the quadratic formula used to solve a quadratic equation? The algebra formula a plus b whole square equal to a square plus 2ab plus b square is used to solve the quadratic equation and derive the quadratic formula. This algebraic formula is used to manipulate the quadratic equation and derive the quadratic formula to find the roots of the equation. Now, we would like to go through multiple realistic examples. I'm going to share my ideas of 3 examples, realistic examples. We can dig into it. How this quadratic formula is useful to resolve these problems. If you look at the example 1, we're going to find out the maximum height attained by the ball. If you look into the example 1, a ball is shot from a cannon into the air with an upward velocity of 40 feet per second. The equation that gives the height of the ball at any time is h times t equals to negative 16t squared plus 4t ft plus 1.55. And now we're going to find out the maximum height attained by the ball. Let's first take a minute to understand the problem and what it means. We know that the ball is being shot from the cannon. So imagine a cannon is firing a ball. We know that the ball is going to shoot from the cannon, go into the air, and then fall onto the ground. So if you see into the picture, now let's talk about what each of this problem means. In our equation that we are given must be the value for the force of gravity, which is coefficient of t squared. We must also use our upward velocity, which is coefficient of t, and our original height of the cannon or ball. So if you see h times t equals to a negative 16t squared plus 40t plus 1.5. H times t is the height in terms of the time. Negative 16 represents the value of the force of gravity. This is pretty standard. You will see negative 16 when working with feet, and then negative 4.9 when working with the meters. 40 represents the upward velocity given in the problem. 1.5 represents the height of the projectile at the time of the launch. The ball is shot from the cannon, which is 1.5 feet off the ground. Now, that you have a picture, what's happening, and then we can understand the formula given. We can go ahead and solve the problem. Let's see how we can solve the problem. First, we're asked to find out the maximum height. If you look into the diagram, what part of the parabola is this? Yes, it is the vertex. We will need to use the vertex formula, and then we will need to know the y coordinate of the vertex because it's asking us the height. What is the next step? Now that we know that we need to use the vertex formula, I can get it to work. In order to find the maximum height of the ball, I will need to find out the y coordinate of the vertex. The vertex formula is x equals to negative b divided by 2a, which is h times t equals to, as we know, negative 16 times t squared plus 40t plus 1.5, where a equals to negative 16, b equals to 40, c equals to 1.5. Now, x equals to negative 40 divided by 2 times negative 16, where x equal to, now x equal to 1.25 or t equal to 1.25. T represents the time and is the x coordinate in this formula. Now, substitute 1.25 into the functions and solve for h times t. Now h times t equals to negative 16 times 1.25 squared plus 40 times 1.25 plus 1.5. That gives h times t equal to 26.5 feet. Now the maximum height of the ball is 26.5 feet, which occurred at 1.25 seconds. The problem is solved. We don't need to stop here. We can take this simple problem and we can put a twist on that. There are many other things that we can find out about this ball. We can go to the example number 2. And here, if we go to the example 2, we can also find out how long did it take the ball to reach the ground. Maybe it's the same problem, but a different question. We can take a look into this. As we know, the ball is shot from cannon into the air, an upward velocity 40 feet per second. The equation that gives the height of the ball and time is h times t, 16, negative 16 squared plus 40 feet plus 1.55. Now we can calculate how long it is taking for the ball to reach the ground. Now, as we change the question, we want to know how long did it take the ball to reach the ground. You can ask what ground. The problem didn't mention anything about the ground. Let's take a look at the picture in our mind again. You see where the ball must fall to the ground? The x-axis is our ground. In this problem, what do we know about the points on x-axis when we are dealing with quadratic equations and parabola? Yes. The points on the x-axis are our zeros or x-intercepts. This means that we must solve the quadratic equation in order to find the x-intercepts. Let's do it. Let's solve the equation. I'm thinking that this may not be a factorial equation. I hope you agree. Then what is our solution? Hopefully you agree that we can use the quadratic formula to solve this equation. Now let's get into it. H times t equals to, as we know, negative 16 times t squared plus 40t plus 1.5. where A equals to negative 16, B equals to 40, C equals to 1.5. As we know the formula, x equals to negative b plus or minus square root of b square minus 4ac by 2a. Now x equals to, if we apply the variables, negative 40 plus or minus square root of 40 square minus 4 and minus 16 times 1.5 divided by 2 times negative 16, where we get the x equals to negative 40 plus or minus square root of 1696 divided by negative 32, where we see x equal to negative 40 plus 1696 square root divided by 32, or x equal to negative 40 minus square root of 1696 by negative 32. Now where we get x equal to 0.037, x equal to 2.55. So the ball landed on the ground in 2.454 seconds. The first term doesn't make sense because it's a negative. This is the calculation for when the ball was on the ground initially before it was shot. This actually never really occurred because the ball was shot from the cannon and was never shot from the ground. Therefore, we will disregard this negative answer. The other answer was 2.54 seconds, which is the ball reached the ground, x-axis, after it was shot. Therefore, this is the only correct answer to this problem. After finishing these two problems, one more problem is spinning up. What would you do in this case? Let's go into problem number 3. And in this problem, based on about 2 problems, we're going to see how long does it take the ball to reach the height of 20 feet. The ball is shot from the cannon, again as we know, into the air with upward velocity 40 feet per second. The equation that gives the height h of the ball at any time t, h times t equals to negative 16 t squared plus 40 t plus 1.5, as we've been seen in other 2 examples, realistic examples. Yes, the problem is a little tricky because the question is not asking for the maximum height or the time taken. It is asking for the time it takes to reach a height of 20 feet. I'm repeating. For the time it takes to reach the feet of the 20 feet. Now, since the ball reaches the maximum height of 26.5 feet, we know that it will reach a height of 20 feet on the way up and then the way down. Let's just estimate on our graph and also make sure we get this visual in our head. If you look into this graph, I would estimate the times to be about 0.7 seconds and 1.9 seconds. You see how the ball will reach 20 feet on the way up and on the way down? Now let's find out the actual values. Where will we substitute 20 feet? Yes. We must substitute 20 feet for height times t because this is a given height. We will now be solving for t using the quadratic formula. Let's take a look into it. H times t, as we know, the formula is h times t equals to negative 16t squared plus 40t plus 1.5. Substitute 20 for h times t, since this is a height we are solving for. So if we apply the values very here, 20 equals to negative 16 times t squared plus 40 times t plus 1.5. In order to solve a quadratic equation, the equation must be set equal to 0. Therefore, we need to subtract 20 from both sides. 20 minus 20 equals to negative 16 times t squared plus 40 times t plus 1.5 minus 20. We get 0 on the left-hand side equals to negative 16 times t square plus 40t minus 8.8815. This is a new equation. Now, a equals to negative 16 and b equals to 40, c equals to negative 18.5. We know the formula x equal to a negative b plus or minus square root of b square minus 4ac by 2a. Now x equal to negative 40 plus or minus square root of 40 square minus 4 times minus 16 minus 18.5 divided by 2 times negative 16. And now when we simplify this, x equals to negative 40 plus or minus square root of 1416 divided by negative 38. And now if we further simplify, x equal to negative 40 plus 416 square root divided by minus 32, or x equal to negative 40 minus square root of 416 divided by negative 32. Now we get x equal to 0.61 and x equal to 1.88. The ball reached a height of 20 feet at 0.61 seconds and 1.88 seconds. Our actual times were pretty close to our estimates. Just don't forget that when we solve quadratic equations, you must have equations set equal to 0. Therefore, we have to subtract 20 from both sides in order to have the equation set to 0. Now we have seen all multiple different circumstances, 3 different examples we have seen. And like this, there are so many examples that we can find out in this world to solve the problems. And many people use this quadratic equation. I would like to thank, I hope you enjoyed my presentation and ideas. And I would like to thank each and every one of great people that got an opportunity, that gave the opportunity for me. And I hope you have a wonderful day. Please be safe. Thank you.
Thank you very much, sir. Sri B. Solomon Raju garu, for introducing the quadratic equations in a different perspective to find the time taken to reach the ground by the ball thrown into the air, and also how you have linked the trajectory to the quadratic equations. So thank you very much, sir, Sri B. Solomon Raju. Now I invite the next resource person, Sri Dr. R. Ambrose Babu garu. So, but before that, I will introduce him to you. I have the pleasure in introducing Dr. R. Ambrose Babu, Associate Professor, DMI College of Engineering, Chennai. He completed BSc Mathematics and also MSc Mathematics from University of Madras, Chennai, and passed in first class with distinction. He obtained his MPhil in Mathematics from Alagappa University, Karaikudi, Tamil Nadu, and obtained his PhD in Mathematics from Anna University, Chennai. He has published 22 research papers in the reputed national and international journals, and 5 more are in offering. And he has published his research work in ample number of conference proceedings. He has participated in more than 20 workshops organized by different reputed institutions. He acted as resource person for a good number of seminars organized by different institutions. And he himself has organized 10 conferences. He had more than 20 years of teaching experience. He is a systematic, sincere, and committed person. He worked as examination cell coordinator for conducting the Anna University examinations for 4 years. He also acted as the head of the department and coordinator for some programs in their universities. Now I am very happy to invite Dr. R. Ambrose Babu to deliver his lecture on the applications of mathematics and statistics in our daily life. So now I invite Dr. R. Ambrose Babu.
Thank you, Mr. Maria Das, sir, for your nice and brief introduction about me. I hope you are all able to hear my voice and also my video.
Yes, sir. Yes, sir. You are audible.
Yeah, let me present. Yeah, can you see the screen, sir?
Yes, sir. It is visible.
Yeah, thank you. So before going to the lecture, first of all, I would like to thank the principal, Andhra Loyola College, Vijayawada, HOD and Director, ALC, ICR, TMS, convener and organizer of this international e-conference. So, my name is Dr. R. Ambrose Babu, Associate Professor, Science and Humanities, DMA College of Engineering, Chennai. So my topic is application of mathematics and statistics in our daily life. So yesterday also, I think in the second lecture, Mr. Francis Shauri Kumar, Engineering Manager, Texas, USA, he was giving a lecture on statistics also. Most probably, my view and his view may be the same, but the side may be a different one. Anyhow, let us see this. So I have divided my lecture into 5 parts. So the first division, or the stage 1 is introduction to statistics. Stage 2, descriptive versus inferential statistics. What is the difference between the descriptive and the inferential statistics? The stage 3, understanding variable types. Stage 4, applications of statistics, and finally in stage 5, applications of mathematics which we are using in our daily life without knowing that. Okay, so I hope it may be interesting for you. So before moving on to the session, can you identify this personality? Can you identify this personality, anyone? Okay, I'll give you one more picture. Now I hope you can identify this personality. Anyone else? Okay, let me give you some clue. He was an Indian industrialist and aviator who was born to a French mother and grew up in France. And meeting pioneer Louis Blériot sparked his aviation interest. It was one of India's great conglomerates with business as diverse as steel, power, and hotels. By 1929, he had given up his French citizenship and became licensed as one of India's first commercial pilots. Over the next years, he established Tata Airmail. By this time, you must have identified who the personality is, which became the Tata Airlines and then Air India. Anyone else? Okay, I will reveal this. He is J.R.D. Tata. Why I have chosen this personality to this particular date? Can anyone answer my question? Okay. So he born today. So 29th July is birthday. So that is why purposefully I have chosen his name. Okay. Now let's go to the statistics. So what is statistics? Statistics is nothing but the science of collection, organizing, presenting, analyzing, and interpreting a data to help in making more effective decisions. For example, suppose you are running a business in online selling company or you must be the owner, okay, want to send a campaign to the customers. You send the campaign to others and you don't want to send the campaigns to the other people, set of people. And if you want to know whether the customers are going to buy based on campaign or not, whether the company is effective or not, how do you design the experiment? Whether to send or whom not to send. How do you figure out how many of them to send? And once it has happened, and suppose the customers who got the advertisement clicked on it and purchased a little more, and who has not received that advertisement may not click on it, they may not be able to buy. So to answer all these questions, we do statistics. Statistics analysis is implemented to manipulate, summarize, and investigate the collected data so that it is useful for our decision making. Information results are obtained. So what are the types of statistics? We have descriptive statistics. What is descriptive statistics and what is inferential statistics? It is the method of organizing, summarizing, and presenting the data in an informative way. I'll give you an example for a descriptive statistics. For example, we have all the data, say how your business is going on, how much inventory you keep, how many customers reaches you for your business, or whatever may be the case, in which month your business attained its peak, which product sells more at what point of time, what kind of customers reaches your shop or reduce frequently. Is it a male customer visits your shop frequently, or a female customer, or it may be a children, or maybe the grocery buyers visit quite often. All these data are answered by descriptive statistics. Then what is inferential statistics? It is a method which is used in determining something about a population on the basis of a sample. For example, let me tell you what is inferential statistics with an example. Recently, we had an election in our country, in few states. Am I right or not? So, of course, in Tamil Nadu also, we had an election. So, eligible person, that means those who attain 18 years of age have to go on vote for the party, A or B or C or D, whatever may be the case. How do you figure out whether this particular person is going to vote for party A or party B or other parties? But you want to figure it out. So, you need to select a sample. You decide the sample size, and based on that sample size, you try to infer which party is going to get more number of votes. Right? So for this, we need inferential statistics. You have to infer that. Whether the person is saying that the truth while mocking in poll is taking place. That becomes inferential statistics. So the population is all the individuals of the state, say in particular Tamil Nadu or in Andhra people voted, and sample would be those people whom you went and asked. Party B or party C or party D. This is nothing but the definition or the example of the inferential statistics. The next thing is we are going to discuss about descriptive statistics and inferential statistics. What comes here? In descriptive statistics, we have central tendency, data distribution, skewness, correlation. And of course, in central descriptive statistics, in central, particularly in central tendency, we have mean, median, mode, all these things that we'll be having. Am I right? So what is mean? Nothing but the average. What is median? Median is a statistical measure that determines the middle value of a data set listed either in ascending order or in descending order. What about the mode? The mode is nothing but the value which is repeatedly occurring in a given set. To find the skewness, what is the formula? Some textbook, they use the formula skewness is equal to mean minus mode product 3 whole divided by standard deviation. Skewness is nothing but the measure of the symmetry of a distribution. Okay, then in inferential statistics, of course, you know what about the meaning of a correlation, all these things. Correlation value should lie between -1 and +1, and data distribution. So we have to distribute the data, and all these things can be figured out by using the either histogram or pie chart or bar graph or any other suitable diagrams. Okay, so what about inferential statistics? So inferential statistics comes under hypothesis testing, confidence interval, and regression analysis. See, regression analysis, you can predict by using regression analysis, you can predict the future, isn't it? Suppose you have in 1970, 1980, 1990, you have the rainfall. So in 2000, what would be the rainfall? So therefore, we can predict. Similarly, in numerical method also, we have Lagrangian method. So using this Lagrangian method, we can predict. The same thing can be used by using the statistical tool called regression analysis. Next one is variability. See, around the world, we have a lot of variability. I have chosen a particular variability in order to satisfy our statistical tool. What are they? See, height. We were dealing with height, isn't it? Some important problems are there. Suppose two sailors are there, then normal persons are there. They'll be giving you the average of the sailors or the soldiers, and we have to check whether sailor are taller than the soldier or soldier is taller than the sailor. So to identify this, we have a collected data. By using the collected data, we can use a particular tool, either the t-test or the student t-test or normal distribution. Large sample, accordingly, we can check whether it is possible or not, isn't it? So we can decide who is taller than the other. The next one is, say, weight. Similarly, for like height, we can go for weight also. We can check the weight also. Similarly, hair color. And then finally, food preferences. All these things are there. Just I have chosen, many variables are there, but I have chosen a few. Next one is, we have variables. What are we going to study? Categorized variables are there, countable variables are there, measurable variables. So we will see one by one. First, I'll go with measurable variables. So in measurable variables, we have two data. What are they? Quantitative data and categorical data. In quantitative data, what do you mean by quantitative data? Measured in numbers. That means it makes sense with arithmetic calculations. So quantitative variables comes under height, weight, and midterm score, right? And whereas in categorical data, it refers to the values that place things into different categories. So we'll see that. What do we mean by that? Categorical variables comes under categorical data. The examples are hair color, letter grade, cat types. Those are all comes under the categorical variables. So what is categorical variable? So in categorical variable, we have two cases. One is categorical and ordinal, and the next one is categorical and nominal. Categorical and nominal. See, what do you mean by categorical and ordinal? Logical ordering to the values of a categorical variable. For example, I can take a letter grade. That is, see here I have given F, C, C plus B, B plus A plus. I have arranged the grade of a particular student in ascending order. If you get less than 50, it means F grade. 50 to 60, C grade. 60 to 61 to 70, C plus. 71 to 80, B grade. 81 to 90, B plus. 91 to 95, A, and 96 to 100, A plus, right? In some colleges or some schools, they will be having even O grade, all these things. Okay. So I have chosen accordingly in the ascending order. Whereas categorical nominal is nothing but there is no logical sequence, no logical ordering. For example, I can take the hair color. In the hair color, some people have blonde hair. Okay, that is no hair at all. And some people having blue hair color. Artificially, they may be using some brown color, red color. If I arrange, okay, blonde hair to the last, blue to the first. If I arrange any order, it makes no sense. That means there is no logical. That is the meaning of categorical and nominal. Okay. Then the next one is quantitative variable. What do you mean by a quantitative variable? In quantitative variable, already we have seen the definition. We have two cases. One is discrete. Okay. What do you mean by discrete one? Refer to variables that can only be measured in certain numbers. Clear? The example. Numbers of pet you own. Numbers of pet you own. How many cats do you have at home, or how many dogs do you have at home? You may have 0. You may have 2 pets. You may have 3 pets. You may have 4 pets, but you cannot have 4.2 pets. Am I right or not? So that is called a discrete one. Then what about continuous one? Continuous refers to variables that can take on any numerical value. So I can take the weight of a particular person. The weight of a particular person can be 65, it can be 75, it can be 86.25 also, right? See, this quantitative variable plays a vital role in our day-to-day life applications. See, the discrete and continuous. See, those days, okay, we were using phone, just a dialed phone. When we were dialing a phone, so one who receives a call will not be able to know who the person is calling. Am I right or not? After introducing themselves, then only they will come to know so and so is calling. So therefore, that means we were using only the continuous case, continuous functions. Whereas nowadays, we were using both the discrete as well as the continuous. That is why the discrete gives you the number. So it will be a form of a string. When I dial a number to my friend Mr. Das, Maria Das, so he can view my number, or he can view my name if my name has been stored in his mobile phone. How is it possible? Only because of the discrete case. So when I'm calling, so it will be in the form of a wave. Then it can be converted to a string, and that string can be converted to a binary form that is nothing but the numbers or the name. All this happens within a nanosecond. Everything happens within a nanosecond. All this happens because of a discrete and also the continuous. Continuous function, okay, it fasten you the process, whereas discrete gives you the number. So this is the ultimate aim of a discrete and the continuous functions. Remember, all the applications that we are using, there will be an equation behind that application. Okay, so mathematics plays a vital role everywhere. That is what we are going to see in a few slides from now. That means statistics everywhere and also mathematics everywhere. Statistics in everything. Statistics in everything. So, you know, as I told you earlier, statistics means collecting, analyzing, organizing, and interpreting. So, we have to collect a sample. We have a population. We have to collect a sample, and we have to analyze, and then we have to organize, and then we have to come to the conclusion whether they said is correct or not. For example, a TV company owner, he says that my TV will last long for more than 10 years. Okay, we cannot accept his statement as such. We have to examine his statement. How do you examine? There is a tool called statistics tool. Many tools are there in statistics, isn't it? We have large large sample test, small sample test, then chi-square distribution. Many tools are there. ANOVA distribution. Many tools are there. We can use any one of this appropriately. Then we can come to the conclusion his statement is correct or not. Of course, I'm going to use a slide, two slides, just as an example. Okay, I mean the mathematical tool. So now mathematical equations comes into play, right? So how statistics plays a vital role in our daily life? Whenever we deal with numbers, okay, numbers or equations, mathematical equations comes into play. So now let us talk about the numbers and calculations. Mathematical equations comes into play, and then they bring the statistics along with. So let's get right into it. Now, see how statistics plays a vital role in our daily life. Say, for example, today is so hot. Okay, let's see in the picture. Today is the day I melt away. Maybe because of so hot during summer season, we feel very hot, isn't it? So it may be raining the temperature. Is it going to rain? It may be 25 degrees Celsius or it may be 35 degrees Celsius tomorrow, right? We cannot predict, but we can predict. It depends upon the situation and of course the statistical tool. There may be a crash in stock market also, and many suffer the huge loss. Need to make our investment properly. There we are going to use the statistics. Is it limited to the temperature or stock market or the money or in the sports? Even in sports, even in cricket, they are using the statistics. Everywhere they are using the statistics. No, statistics plays a vital role in all the departments. We are going to see one by one, okay, in the few slides from now. So when we talk about numbers, as I told you earlier, and calculations, mathematical equations comes into play. Let's see about the statistics and also mathematics. Probability, dispersion, basic averages. Yes, what percentage of marks that you have obtained? Okay, what would be the average? Score is all mathematics, but the way you are involved in gathering the data and analyzing it before jumping into the results is called the application of statistics. Okay, right. So even in stock market we are using the statistics. That is, for example, an investor can use statistics to perform research and analysis of the stock market and determine how to improve the performance and investment portfolio. For example, an investor could perform hypothesis testing of a mutual funds, claim that it can consistently deliver and some 9% annual return or some X% annual return. So even in stock market, we are using the statistics. What about in business planning? Of course, in business planning also, we are using statistics. For example, you can study the investment types with the help of data that we have collected. Also, how to earn extra pocket money is also a statistics. We have been talking about statistics without even realizing in our daily life. Then what about in healthcare? Of course, in healthcare we are using, isn't it? In healthcare, by taking complete details of the population with respect to the demographic and various other factors, also the medical history such as blood pressure, temperature, and the overall physical health is also statistics. Nowadays, we are having the Covaxin or Covishield. So we are having the statistics. How many of them have cured? Every statistics are available. Based on the statistics, we are applying the Covaxin or Covishield. So how effective it is. All these things we are having the statistics. So they are realizing. So this Covishield and Covaxin is more effective, not to prevent the pandemic diseases, right? Such as COVID-19, right? What about in finance? Statistics in finance, yes. Your pocket money expenditure saving associated with your financial health can also be managed by statistics. Even the government rely on statistical data to make huge policies that affects the trade or millions of us. Even I can think about the statistics can be applied effectively in the banking sector and also in the genetics. See, in banking sector it can be used, and also in the genetics we can apply the statistics. So remember, statistics plays a vital role in our daily life and in every moment. So numbers are generated everywhere. Statistics extract the information. Now, I'll just give you slides on analytical representation. Calculate a per t test by hands for the following data. So we have the data, 10, 11 subjects are there, and the particular student score, okay, is given 3, 3, 3, etc., and also in score 2. So for example, you can take internal assessment 1 and internal assessment 2. So subject, okay, it is given and score is given, score 2 is given. So I'm going to use the formula. So this is the formula. So t is equal to, so we have, yes, I'm using the t test because it's a what? Small sample which is less than 30, so I'm preferring t test. This is the formula, summation d by n divided by square root of summation d square by, minus summation d whole square by n divided by n minus 1 into n. So of course you know all these things, so I'm skipping this and using those values, I'm getting the value t equal to minus 2.74, and the table value. How to find table value? To find the table value, I want to go for the degree of freedom. So n is equal to 11. So n minus 1 is equal to 10. So the table value is 2.228. Here, the table value is 2.228 and the calculated value is 2.74. I have to take only the absolute value of t. That means I have to neglect negative value. So 2.74 is the calculated value and 2.228 is the table value. So as you all know, calculated value is less than the table value. So I have to reject H0. Yeah, and you know what would be the case, right? Now, before moving on to the next step, that is the mathematics. So far we have been dealing with statistics. Now let us see some applications of mathematical equations which we are using in our daily life without realizing. So can you tell me who the personality is? Okay, one more. I'll give you the clue also. So he was a statistician and geneticist who is credited for setting the course of modern statistics. Many of the important concepts in statistics are his contribution, particularly maximum likelihood. It is his contribution.
I think he is R.A. Fisher.
Okay, correct, exactly. Correct. Ronald Fisher. Why I have chosen, can you tell me? Because he died today. So died 29th July 1962. Anyhow, thanks for your answer. Now, application of mathematics. So I'm going to say a few applications, in particular complex numbers. So, and complex analysis shows up everywhere in mathematics and physics. Algebraically, complex numbers are closed. This is a good algebraic property for a field. They have been studied in mathematics since the 17th century because of their applications to mathematics, mechanics, waves, etc. Even in signal processing, complex analysis and Fourier analysis. For example, say I have given Fourier analysis. Even in Fourier transform, we were using in our daily life. Every day we are using. While we are going in car, we are using that particular Fourier transform application. Can anyone say what application is that, or what equation is that? You know, frequency modulation property. F of x cos ax equal to 1 by 2 f of s plus a plus f of s minus a. So you know what is frequency modulation? What is the short form of frequency modulation? FM. So when we were going by car, we used to hear songs by using FM, radio, right? FM is nothing but frequency modulation. We are hearing the songs just because of that particular equation of Fourier transform, that is frequency modulation property. So whenever we hear songs or through FM radio, we should thank that particular frequency modulation property, right? So, and also in signals. Sorry. Okay. So basically, if you search for application of signal processing, those are the applications that are indirectly the application of complex analysis, right? Even in two-dimensional problems involving Laplace equation, for example, heat flow, fluid flow, electrostatics, are often solved using complex analysis. In particular, conformal mapping. You know what is the meaning of a conformal mapping? We can transform one plane to another plane under certain transformation. If it preserves both magnitude and direction, then it is said to be as a conformal mapping, right? So in complex analysis, I am going to stick on to a transformation or a mapping. Okay, so it is used to launch a satellite also. Okay, we have Z plane, but in space we have a W plane as well. So to study various factors, we use transformation. Okay, we have a building, right? So suppose you are shifting the house from one place, you are going to shift to the other place. Nowadays, they are shifting the building itself. Of course, you know that. So I am going to shift the building from one place to another place. So it preserves the conformal mapping. So I am not going to change the magnitude and the direction. It's such as it is. From one place, I have shifted to another place. Now, we are going to use the translation called W equal to Z plus C. This transformation name is called translation. Of course, we were teaching also, isn't it? So all the mathematicians should be knowing this translation, W equal to Z plus C. So we are shifting from one place to another place. Just shift it. Okay. but the magnitude is the same, the size is the same, the direction might be the same. So it is called as a translation. So to transform from one place to another place, the equation that we are using is W equal to Z plus C. You know what is W? U plus ID. Z is nothing but X plus IY, and C is nothing but the complex constant. The next one. See, we used to see the stars. We used to see this moon, sun, etc., etc. So that means we want to enlarge. So recently, I saw in YouTube, they were using a particular camera and they were enlarging the moon, okay, as a huge moon, as if we are seeing just a few meters away. So in such a way, they are zooming by using that particular camera. And of course, you can use the telescope and you can zoom it. You can magnify that and you can view that. So we can view the stars, sun, moon, whatever may be. So what's the transformation that we are using, or the equation that we are using? W equal to CZ. That C matters here, the complex constant. See, that C can be 3 plus 2y, 5 plus 2y, 5 minus 2y. Depends upon this complex constant, it can magnify or it can be shrink. Okay, in telescope or in microscope, we can view the small tiny viruses. We can enlarge. Similarly, if you use the lens we were playing when we were the kid, we were used to play the lens. Okay, so when we just change the position, we can see the particles. It can be magnified or it can be shrink, isn't it? So W equal to CZ. That is the equation which plays a vital role to magnify or to shrink the particles behind us or before us. That is called, the transformation is called magnification. Magnification means it can be enlarged, it can be shrinked also. Then what about this? One eye, okay? Then we have a PowerPoint presentation, projector. So I am going to see a film or a lecture by using the projector. I am going to use the PowerPoint presentation. So what's the transformation? What's the equation that we are using in order to get the image? It is nothing but W equal to 1 by Z. It is called as inversion and rotation. It is called as inversion and rotation. See, you must have noticed, if you see a cinema projector or our PowerPoint projector, if you see that lens directly, you can see the image, inverse image. Okay, up, not direct image, inverse image. Am I right or not? Hello? Yeah. So inverse image, isn't it? So when you see in the 70 mm screen or directly, we are seeing the direct image. So it rotates and it gives you the direct image. So that is called inversion and rotation. So even in suppose I want to see the mirror, left will be right, right will be left, isn't it? So that is called inversion and rotation. So this is the equation that we are using in our PowerPoint presentation or in the screen also. Now see, you can see the aeroplane. Okay. So those days we had Concorde aircraft that ran between France and USA, I think so, right? So it was the fastest flight those days, and they were the engineers were trying to build this wings by using an equation called W equal to Z plus 1 by Z. So this is the equation used to construct a wing. Okay, so engineers said that this is the equation that we were using. Okay, but as a mathematicians, we know how to invent an equation, but we do not know how to interpret or how to use those equations in our daily life. So when we have joined hands with the engineers, I think we can do wonders. So let us do research together. So when I was doing my research, okay, and this is my ultimate equation. So in the open unit disk, we can, so this is an analytic function. So if it is an analytic function, we can represent the form of a Taylor series. So this Taylor series expansion in the open unit disk is f of z is equal to z plus summation n equal to 2 to infinity a n z power n. If I expand this, same, f of z equal to z plus a to z square plus a3 z cube, etc. Okay. So z plus a to z square. So a2, the coefficient of z square is a2. Just observe carefully, the coefficient of z square is a2 Z cube is A3 and Z power 4 is A4. In general, Z power n is AN. Okay. Same. So usually in this field, okay, the researchers used to play with these coefficients A2, A3, A4. Usually the A2 value should be less than or equal to 2. A3 value should be less than or equal to 3. In general, AN value should be less than or equal to n. If you say that A2 is equal to 2, A3 equal to 3, then that equation or that function should be short. Okay, so those who have done research in complex analysis, that particularly in geometric function theory, you must be knowing that. So my future research is, I'm thinking about that. See, I'm going to relate this A2, A3, A4, etc. to a particular wave, sinusoidal wave. It may be a sine wave or cos wave or different waves are there. Because see, nowadays researchers or the engineers or the scientists, they are able to locate the natural resources which lies underneath the ground. For example, say water, coal, diamond, gold, etc., etc. Even in water, we have different varieties: pH1, pH2, etc., salt water, etc. Whether that particular water is available in that ground, how do we know? Only we dig, we will come to know. Okay. In those ancient days, they were having different tricks, but now, okay, we have different ideas with different tools. Even then, sometimes it may be a failure. So they are locating the underneath resources just by using the waves. So for each and everything, we have a different way. For example, suppose I take a mobile number. For my mobile number, I have a different unique way. For your mobile number, you have a different unique way. So million people are using a different number. So it is different. Even Aadhaar card, it is different. We have unique way, right? So everyone is having a unique way for their particular mobile number. Likewise, for every natural resources, we have a unique way. I am trying to locate or correlate this coefficients and also with the weights. So if I correlate, suppose I get A2 value is this, and this can be correlated with gold, or A3 value is this, that value can be correlated with the particular natural resources along with the sinusoidal wave. For that, I need an algorithm called Livingston algorithm. So if anybody is interested, you can join hands with me and we can do research, and it will be a wonder for us. Easily we can identify, without no cost, we can identify natural resources which are available underneath the ground. Similarly, we can extend for other cases also. Okay? And of course, one more thing I want to tell you, but it is not there in the slide. I forgot to include in that slide. Cauchy residue theorem. We must have used everywhere in Cauchy residue theorem. We were teaching this Cauchy residue theorem. We are using this Cauchy residue theorem in our daily life. Where? Suppose I keep mum. Okay, I am not delivering a lecture. What are the sounds that you can hear? Can you tell me? Sorry. What are the sounds that you can hear? Can you tell me? I can hear my fan sound. Outside somebody is selling those sounds. But when I am talking, you can listen only my sound. Am I right or not? You can listen only my sound, no other sound, or only my voice, no other voice. How is it possible? In our eardrum, we have that eardrum filters, or residue is nothing but called filters. Okay, deposits. So it filters all other sounds and it gives you only the sound that we require. Similarly, even in our kitchen, we are using that residue theorem, where coffee we can filter the residue. Similarly, we are using in our daily life in TV or in mobile phone. Suppose in TV, for example, you see how many channels are there? Nowadays we have 1,000 channels. Suppose I want sport channels. I just press the number. It filters all other channels and it gives you the channels that you require. All this because of the Cauchy residue theorem. So wherever we go, mathematics follows. Mathematical equation follows. Okay. So I think with this I will stop. Thank you for your patience listening.
Thank you very much, Professor Dr. R. Ambrose Babu,
Thank
for
you.
your meaningful lecture. He did his PhD in complex analysis,
Yes, sir. Yes.
but he is not a complicated person. He is neither a complex person. He is easily approachable and very admiring. So we are very fortunate to have you as our resource person. Thank you very much, Dr. R. Ambrose Babu.
Thank you.
So we will continue for the next session, next lecture. So thank you. Thank you. Now I invite the third speaker of today's conference, Dr. P.R. Tripura Sundari. Dr. P.R. Tripura Sundari. Madam.
Good morning, sir. Good morning. I am here.
Good morning, madam. You can on your
Video.
So I would like to introduce madam to you all. Dr. P.R. Tripura Sundari is working as an associate professor, Department of Mathematics, DMI College of Engineering, Chennai. She obtained her BSc degree from SDNB Vaishnav College for Women, MSc from IIT Madras, MPhil from Madras.
Correspondent, principal, organizing secretary, head of the department, convener, and all the other co-conveners and committee members for organizing this knowledge sharing session, as well as it is not only the knowledge sharing as well as knowledge gaining for the research scholars during this pandemic. I'm also delighted to be here to deliver my lecture. The topic of today's talk is inventory optimization in reverse supply chain with remanufacturing. Is it audible and are you able to see the screen, sir?
Yes, madam. Yes, it is very clear.
Okay. The talk is being organized in this order: optimization concepts, then comes supply chain management, the concepts of inventory optimization we can have an overlook, and reverse supply chain, and finally comes the model related to reverse supply chain. Operations research came into existence during World War II for the resources, optimal uses of the available resources. Whenever we hear the word operations research, the first thing comes into our mind is the optimization. Optimization is to obtain the best among the available. Mathematically, it is defined as a mathematical technique in order to find the maximum or minimum value of the function, subject to some constraints, or in some cases we may not have the constraints. Let us have an overview of the history of optimization. Optimization came into existence during 300 BC itself, where Euclid has found that the square has the greatest area other than the rectangle if both are having the same perimeters. There itself optimization came into existence. It is being further developed in 17th and 18th century. Mathematicians has contributed a lot in the area of optimization. Kepler has found the optimal dimensions of wine barrel by approximating the wine barrel with the cylinder. Fermat has shown that the light always travels within a minimum time between 2 points. Isaac Newton has framed the body of minimal distance problem, and Lagrangian has formulated the Plato's problem. Legendre has presented the least square method. Cauchy has presented the gradient method. Weierstrass has presented using the calculation of variation approach. He has found the maximum or minimum value of the function. In 20th century, it has developed a lot, and Kandrovich, the Soviet mathematician, has presented the LP model and an algorithm to solve it also. For this, he has received the Nobel Memorial Prize of Economics. And Harry Zanuck has contributed, and he has first written the textbook on optimization titled Theory of Maxima and Minima in the year 1970. The Denmark mathematician Vladimir Jensen has contributed in the field of convex functions in 1905. In 20th century, these two mathematicians, they are not mathematicians, we can say they are all-rounders, because not only they have refined their field in mathematics, he has developed in the field of mathematics everywhere, statistics, management sciences, everywhere their contribution is there. Von Neumann is an important person for the development of operations research, and Danzig has presented the simplex method for solving the linear programming problem. Let us come into the mathematical part of optimization. If a problem, a real practical problem is posed to us, we have to formulate that into a mathematical problem, finding the variables, equations, etc. Then the mathematical algorithm to be framed to solve that. This mathematical algorithm can be converted to computer algorithm, which is being fed into the decision support software system, and the human decision maker using that software system will come to the optimal solution or near optimal solution to the practical problem. Usually the sequence of solving the problem using mathematical technique is done like this. We will be using optimization everywhere. It exists, we can say it is omnipresent. It exists in architecture, nutrition, circuits, productions, networks, policy modeling, everywhere. In all the fields, we can find the optimization techniques. The optimization problems can be classified into discrete and continuous problem, which is being further branched into constrained, unconstrained, and it can be classified as linear programming, nonlinear constrained problems, differential optimization problem, global optimization problem, nonlinear least square methods. It is still now it is being further branched. The optimization problems can be classified based on the types of constraints and equations. It is based on the types of constraints. Nature of the constraints equations and objective functions equations. These are the few classifications. Classical optimization problem can be solved using two methods. One is known as analytical method, and another one is the classical approach we can solve it, and another one is using heuristic approach. In classical optimization problem, it is an analytical method. We can apply this method using calculus, differential calculus approach, and it is being limited because when we are using the differential calculus approach, the function should be of continuous and differentiable type, but in many practical situations, we may not be able to find the equations, objective functions to be continuous or differentiable. Hence, the limitation exists for the applying classical optimization problem. The main three types of problems applying classical optimization are single variable functions, multivariable functions, and multivariable functions with both equality and inequality constraints. We are very familiar with this. We have solved the problem in school level or college level. We have solved the problem using Lagrangian multiplier method for equality constraints problem. And Kuhn-Tucker condition is being applied for solving the inequality constraints problems. Now comes the meta-heuristic optimization. Heuristic optimization means it's nothing but a thumb rule. It mimics the natural genetics or natural evolution concepts to frame the technique. Meta-heuristic problem always starts with the one or more initial solution. From that initial solution, using the iterative process, more solutions are being generated. From the available solution, the best solution is found, and the iterative process is continued till it satisfies the termination criteria, or if there is no further improvement in the solution. This is the usual process of finding solution using meta-heuristic optimization. The following are some of the methods applied in meta-heuristic optimization. One is simulated annealing. In simulated annealing, it uses the process of sudden cooling of a molten mass to remove its impurity. We now explain the concept of supply chain management system, because optimization concept is being applied in supply chain. Supply chain is the fast going process, because most of us are in pandemic and we were not able to buy goods by going outside. We may rely completely on the online marketing or online purchasing, but supply chain is the best on process technique. Now, supply chain is a network which connects individuals, organizations, resources, activities, and technology in order to create the product and delivery of the product, and also the supply of raw materials in between the supplier and the manufacturer. These processes are said to be the supply chain. Supply chain management is a process which integrates suppliers, manufacturers, distributors, and retailers in order to produce the right quantity of the product. There is a difference between supply chain and supply chain management. In supply chain management, we need to produce the right quantity at right time, and it should be delivered to the customer at right location, so that the customer satisfaction is more important by satisfying the customer. This is the supply chain framework. Here, the supply chain framework has supplier. Already we told that it is an integrating the process of supplier, manufacturer, distributor, retailers, and customers, where there is a flow of goods and information in between all these five. Let me explain this concept using a simple example. If a customer goes and buys a detergent from a retailer, that is from a shop, then the retailer has to stock the goods by getting it from distributor. It is being transported from distributor to the retailer, where the distributor get the product from the manufacturer, where the manufacturer manufactures the products by using the raw materials being supplied by the supplier. Hence, all are interconnected, and this is going to be the supply chain framework. Now, the supply chain drivers. Let us see the performance of supply chain. And first, the competitive strategy. First comes the customer satisfaction. What is the need of the customer we need to find? After that, it is being transformed to supply chain strategy. That means what are the products they have to produce, and what are the raw materials they require, what is the manufacturing process, and what is the time to produce that product. Everything comes under supply chain. All these three are interconnected because inventory plays a vital role in these three logistical drivers. The objective of the supply chain is to maximize the overall value generated by the supply chain, where the value is defined as the difference between the worth of the final product and also the cost incurred during filling the customer's request. Why supply chain management is needed? Supply chain management is needed to reduce the cost, to handle the demand supply scenario in an effective way, for the effective market coverage, and to increase the customer satisfaction, and also for any organization to stay competitive in the global market. Now let us go into the overview of inventory optimization. Inventory is said to be an idle resource kept by any organization to meet the future demand. Inventory management is a policy which monitors the level of inventory to find out what level should be maintained, and when the stock to be replenished and how much to be replenished. This is the process of inventory management. And what is the role of inventory in supply chain? We have already seen inventory is the important logistical driver in the supply chain. It includes the raw materials, work in process, and finished goods within the supply chain. It is a major source of cost in the supply chain. Hence, it has a huge impact on the responsiveness. Hence, inventory plays a vital role for a value generation in the supply chain. Why inventory is needed? To improve the customer services and to improve the economies of purchasing and to improve the economies of production and transportation saving, to meet the future, to be cautious against the future, and to manage the unplanned shocks due to labor strikes, natural disorders, etc. The objective of the supply chain is to reduce the cost involving by investing more on the excess inventories, and to ensure the smooth production by maintaining reasonable stocks, and also the timely and regular supply to the customers for the entire supply, for the entire satisfaction of the customers. The objective of the inventory optimization is to protect the firm against the variations in raw material delivery time and the adequate level of to improve the customer service and to minimize the risk due to obsolescence and deterioration. The following are the costs involved in the inventory. It is inventory carrying cost. It may be called as holding cost or storage cost. It is the proportional to, these costs are proportional to the quantity of material held in the stock. Next comes the shortage cost or stock out cost. Shortage cost or stock out cost comes into play when the customer satisfaction is not met. That is known as shortage cost. And purchase cost is the purchase price of the item. Ordering cost is the cost associated in setting up the for manufacturing or in ordering, the process of ordering. The following are the components of the inventory. They are demand. Demand already we know, it is the number of units required per period, and lead time is the time between placing the order and receipt of the material. Order cycle is the time between the placement of two successive orders. Back order exists when we were not able to satisfy the customer, then that quantity can be ordered in the future events. While ordering for future, we can order that quantity. That is said to be the back order quantity. It is always because we may not sure whether customer will buy it in the next order, or it may be sold, or it may not be sold. Next is reorder level. Reorder level is the inventory level which an organization to maintain to satisfy the customer demand. Now, inventory policies are classified into continuous review policy and periodic review policy. In continuous review policy, the inventory level is monitored regularly, and the order is being placed when the quantity reaches its reorder level. And this continuous review policy is very expensive, and usually it is maintained in the distributor level or in the supplier level. Now, periodic review policy, the inventory is monitored at regular intervals of time, and the order is being placed at fixed interval of time. They may not know whether the quantity is there or not, but at fixed interval of time, they may order for the new products, and it is less cost compared to continuous review policy. It is less cost in workers is less, but it is used by the small retail stores, drug stores, and groceries, etc. Inventory model is classified into deterministic inventory model and stochastic inventory model. This classification is made depends on the demand perception. If the demand is deterministic, then it is said to be deterministic inventory model. Here, the stock out is not allowed at all. It is being further classified as static and dynamic model. In static model, demand is constant, but in dynamic model, the demand varies. In stochastic inventory model, demand and lead time are not known, and hence since due to the uncertainty, we may attach the probabilistic distribution to the stochastic inventory model. Now, let us see reverse supply chain. Reverse supply chain or reverse logistic is the series of activities which includes the upstream, that is, we have seen the supply chain where the supply chain flows from the supplier to the customer. But in reverse supply chain, it is in the reverse order. The flow is from customer to the supplier, where the products, the used products or the product which is not satisfy the specification are collected from the customers and it is being sent to the suppliers for remanufacturing or reuse. This process is known as reverse supply chain. Reverse supply chain, the following are the characteristics of the reverse supply chain. It is convergent in nature from end user to manufacturer. It is the reverse flow of the products and it is considered to be relatively slow. The movement is going to be relatively slow and we may not sure while going the upstream, we may not sure the value may decline. If time goes up, the value of the product may also reduces. Hence, there is a variation in the value of the products and a very small addition in some cases, we may not sure. And also the inventory, we may not know the level of inventory. It is also uncertain. Inventory level is also uncertain. And the following are the industries, organizations which